I wanted to take a few moments to talk about your second exam. Just walk through the prep sheet, did on the last one, highlight a few things that I think are of note. So starting off, know the symbols, just like the last exam. You'll need to know some symbols. I expect you to know those quickly. Those are the types of problems that should take you 10 seconds, 15 seconds, something in that ballpark. Those are not things that you need to be spending a lot of time trying to figure out. Related to that, this exam is going to feel a little bit longer than the last one. So gauge based off of how long you took on the last one. This one's probably going to take you another 10 to 15 minutes. And so if you're a quick test taker and you breeze through the last one, you'll be fine. But I say that because something like the symbols, and we'll talk more about some of these things later, but if you had 80 minutes in that last exam and you took 70 of it, and then you need to be thinking, hey, how do I know these things quick, some of these foundational concepts? It's no different than if you were in a Spanish class. There's some foundational vocabulary. You need to know that el and la are the, it translates to the, right? Those are the foundational things you need to know. You know uno means one, right? Some of those basic things. If you don't have that, then you're gonna kind of struggle, right? Same thing with the symbols. Know those quickly because you're gonna want to spend your time on the other problems. Okay. Differentiate a parameter from a statistic. Remember that parameters are values that come from the population. Statistics are values that come from a sample. It's the idea that in the middle of a problem, there's multiple. Like we talked about this before, right? Every time you have a mean or a proportion or a standard deviation, you should never just say proportion, mean, or standard deviation. You should identify where it comes from. Does it come from the population or does it come from the sample? They have very different meanings, right? The whole purpose of this course is we're going to take statistics, things from the sample, we're going to use that to make an inference on parameters, things from the population. So one is used to make an inference on the other one. We think about a confidence interval. We use statistics to build the confidence interval, and we think that the parameter is somewhere inside of that interval. So be able to understand the difference between those, right? Understand that basic level of understanding is going to help you roll through this test. Differentiate discrete data like binomial from continuous like normal. That's because, and it's kind of similar to number 4, differentiate problems assessing means from those assessing proportions. Just know what you're looking at, right? Know if you see a binomial type setup, that probably is a proportion problem. Now, in that problem, we need to check to make sure it actually is binomial. But that's probably, if it's close to binomial, it's probably a proportion setup, right? It's a series of events where we have two possible outcomes. That binomial-like setup probably leads you to a proportion. A mean problem is going to be something where we just take a whole bunch of values and we're trying to find what the middle of them is, right? Heights and weights and these sort of things all lend themselves to mean problems. Now note, we can flip that mean problem into a proportion problem pretty easily. And you saw an example of that on the last worksheet where we can take something like heights or weights, right? And we can say how many people have a weight above a certain amount, say above 150 pounds. Now we've turned that into a binomial type setup, right? Everybody is a yes, no. That's a binomial type setup that's going to lead to a proportion. What percentage of people are yes out of the total versus just saying what's the average weight of people. So there's a subtle difference there, but just be able to identify that. That'll help you out a lot. Main thing to think through as you're prepping for this test is 20, 20, 20, 20, 20, right? There's 5 buckets that are all about 20%. You've got about 20% are going to be mean probability problems, 20% are proportion probability problems. That's the stuff from chapter 7. Then you've got 20% are mean confidence interval problems and 20% are proportion confidence interval problems. That's the stuff from chapter 8. And then the other 20% just miscellaneous things like that. So it kind of gives you a good idea, but the key, in my opinion, one of the biggest keys is being able to identify what problem is what. What's a confidence interval? What's a proportion? What's sample size determination? What's a mean problem? What's a proportion problem? If you can identify that, that's half the battle right there. So if that gives you a little bit of something to think on there of how can you identify that type of problem beforehand. I said this before, and I'll say it again. If you want, take the problems from the textbook cut them up into little pieces, pull them out of a hat, and just be able to identify what type of problem it is. If you decide you want to work through it if you have the time. I find that the working through part is a little bit easier. Most students tend to grasp that first, and they grasp what type of problem it is later. So that's why I say don't really bother working it out. In that once you've figured out how to work it, just make sure you know how to identify it. Number 5, you saw this one before, convert standard deviation to variance and vice versa. You may see one, you may see the other. You may need to convert, you may not. On the first exam, you had a problem that asked for the standard deviation of a binomial, and you were given the formula for the variance, right? So if you're paying attention to things like that, you should say, oh, the formulas for the variance, I found the variance, now I need a square root to get standard deviation. Doesn't mean it's always going to be like that. Just pay attention to what you have and what you need. And if you need to square or square root, you can do that, right? If you're going from standard deviation to variance, you square it. If you're going from variance to standard deviation, you square root. Know the properties of a discrete probability distribution, know the properties of a binomial distribution, know the properties of a normal z and t distribution. So know all of the distribution properties. Some of these things are things you had before. Discrete probabilities are all between 0 and 1. They all have to add up to 1. Binomial is a subset of a discrete, and those properties are part of it, but also how do we identify a binomial? Once you've identified it, we can use certain formulas to find certain key things. So that's all old hat for you. A normal you had seen before as well. Remember, a normal is a type of continuous distribution, so we think of it in terms of a curve. The probability that you land exactly on something is always 0. We're interested in the area between two values. Area is probability, right? And then now we've talked about the z before. Now we add the t. Remember, there's one z distribution. That's a normal 0, 1, also called a standard normal distribution. A t distribution, there's an infinite number of them, one for each corresponding degrees of freedom. It is centered at 0, but its standard deviation is a little bigger. It has a little bit thicker tails, thus the critical values are going to be a little bit bigger in a t than a z. If you need to go back and watch some of the videos on that from chapter 8, go for it. Make sure you understand those properties. Again, those properties are like what we talked about at the beginning with the symbols. Those are things that you should know relatively quickly. It's not critical thinking. There's going to be some critical thinking on this exam where you have to think through, is there a bias in this problem? Or I have a confidence interval, but what does it mean? Or I've got to think through some of the assumptions. Thinking through some of the assumptions on some of these problems is not straightforward, memorization. It's I got to think through this situation, right? You got to think a little bit. That's where you want to be spending your time. You don't want to be spending your time trying to remember, that the t distribution has thicker tails than the z distribution, or that the t distribution has a larger standard deviation than 1, right? Those are the things that are just kind of memorization. Just make sure you know those key concepts. There's so many concepts that I can throw at you. But my encouragement to you is that as long as you are linking some of these ideas together, it will help you remember them all. So think through, hey, I know a lot about the z, I know a lot about the t, those are related ideas. Link those in your brain a little bit. That way it's not having to memorize 20 different things. It's kind of just saying, I understand these concepts and now I can apply that concept to a couple of different areas, right? You don't have to memorize that the z has a mean of 0 and the t has a mean of 0 and the z and the t have the same mean. Just say, oh, that's all, they're all centered at 0, right? That kind of covers you at 3 different places. So there's a lot of things they can throw at you, but it's kind of based off the same stems. Hopefully that makes sense. Find probabilities and cutoff values for standard and non-standard normal distributions. This is the same thing that you saw last exam. That's from chapter 6. Just be able to do that because those problems can be easily interwoven with the problems from chapter 7 that are questions about means and not individual values. Okay, so just be able to work those interchangeably. You'll be able to identify the problem. You won't see just problems from chapter 7. You may see one from chapter 6 thrown in there. And I'm not gonna jump up and down and say, hey, this is chapter 6, this is chapter 7. You'll need to identify which one it is. Read through the question, right? If the question says, what's the probability that one person or one thing or one city or one whatever has a value that exceeds blank or greater than blank or between blank, that's an individual, it's an X. And then I need to know, okay, well, X, if X is a normal distribution, then it has a mean and a standard deviation sigma. But on a means problem, it's what's the probability that a group of people have a mean of something. Oh, and that's an X bar problem. Now I need to know what the mean and the standard deviation of X bar is, right? And that's where you take the standard deviation sigma, you divide by square root of n, because now it's a means problem. Number 10, know the law of large numbers and central limit theorem. These are the two of the theorems that we're going to ask you to memorize. Make sure you know those. You were asked some questions on this in the last worksheet. Just be able to identify what those say. Assess the distribution of and find probabilities relating to X bar and P. This just says basically know how to do chapter 7. Okay. You've been asked a lot of these questions on the worksheet. I've already kind of shown my hand in the types of things I want to ask you via these worksheets, via the homework problems. I don't have a problem with that. Why is that? So you're going to see some of those same things again. And I'm telling you that. It's not that I'm showing you the answers. It's not that you're cheating. It's that I'm telling you what's important to know. Now go know it. Okay, so I've already asked you a lot of things. You may see a slightly different question. You may see a different twist on a question, but a lot of it's the same stuff. You've already been asked about these. Know the difference between does something have an exact normal distribution or an approximate normal distribution? How do you know the difference, right? We know that p hat always has an approximate normal distribution as long as the conditions are met. It can never be exactly normal. Why is that? The only way we get to exact normality is if x is normal. If x is normal, x bar is normal. That's the only way we get to exact normality. Okay, so p hat can never be exactly normal because in a p hat problem, x is binomial, right? Put these ideas together. And so if I said all that and you're like, whoa, I got to listen to that again, make sure you get to the point where you can listen to that and be like, check, 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 I got it, right? This is the idea that you need to be able to quickly say, p hat problem has an x, that x needs to be binomial. That's one of the assumptions I have to check. If it's binomial, if n times p or n times p hat, depending on if it's a probability or a confidence interval, if n times q or q hat, again, depending on which the problem is, are large enough, then p hat has an approximate normal distribution, right? That's a basic thing that I need you to understand. It's the foundation of what we're doing. When we get to an x bar problem, if x is normally distributed, x bar is normally distributed, exactly. If not, I have to check the sample size. I have to check the shape of the distribution, right? We use 30 as a last resort cutoff. If it's around 30, I don't actually care about 30. I care about what x looks like. If x is symmetric, doesn't matter if n is 25 or 35. If x is really skewed, doesn't matter if n is 25 or 35. If we have a lot of skewness, x bar is not normal. If we have symmetry in those cases, then I would say that x bar is approximately normal, right? So just make sure you can listen through that little spiel and be like, yes, 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 I got all those things. If not, go back, check those videos, make sure you understand how do we get x bar and p hat's distribution, the assumptions that we're checking, and then of course find the probabilities. Then it's downhill from there. Just make sure you're writing out your probability statement. Keep everything as in as in line as you can is my recommendation for you. We've talked about this before, but the more scattered your work is, the more likely that you're going to lose a 1 minus or something of that nature. And the more kind of in line that you keep your work, that's what I do in the slides, right? I kind of say this equals this equals this equals this. That way I haven't lost anything. I don't forget to subtract from 1, or I don't subtract from 1 when I shouldn't. If I didn't write a 1 minus because I didn't flip my probability, I don't subtract from 1. It's not there, right? So just try to be careful when you're working through those chapter 7 problems. Know the properties of a confidence interval, find and interpret them, assess the claims. The confidence interval problems are going to work just like the ones that you've seen in the notes, just like the ones that you see in the homework, just like the ones that you see in the worksheet. They're all slightly different, but they're all the same, right? The wording can be a tiny bit different. I'm not trying to trick you on that. I don't want to confuse you. It's just at some point words can be slightly different, and I don't need that to throw you for a loop, right? But you've seen a lot of different scenarios. You'll see new scenarios, okay? But it's going to be the same concept. We're going to ask for a confidence interval. We're going to make sure that you can, check the assumptions. We're going to ask you to interpret it, write out the sentence that we've been focusing in on. We're going to say, can you make this conclusion, right? If the entire interval agrees, you can make that conclusion. If it doesn't, then you can't make that conclusion, right? So it's the same things that you've been thinking through. You'll see another problem or two that are just like that. 15 and 16 those couple of extra little things there. Be able to find the point estimate margin of error given a confidence interval. Be able to work backwards on that. That's take the endpoints and either add or subtract and divide by 2, depending on if you're looking for the point estimate, the margin of error. Remember, the point estimate's in the middle, so if the average is when you add the two values. The margin of error, we're going to subtract, because if you subtract the upper bound and the lower bound, that's the entire width of the interval. And if I cut that in half, that gives me the margin of error. Sample size, remember we always round up. Doesn't matter if it's 0.1 or 0.7, we always round up. It's the one weird thing that we round in this course. Everything else rounds like normal, 0.5 up, not down. But in this case, we always round up with sample size. And all these problems, remember that when you plug in for a Z or T critical value, you plug in a critical value. You don't plug in alpha. You don't plug in the confidence level, right? So just be careful with those things. And that last one kind of already mentioned, be able to address assumptions and assess their implications. Make sure it's a two-part problem. You need to be able to talk about what the assumptions are, and then you need to be able to say if my results are good or not. The validity of my results is directly proportional to the quality of my assumptions. If my assumptions pass with flying colors, my results are valid. If they are mediocre, my results are mediocre. If my assumptions are really bad, my results are really bad. Okay, so be thinking through those bias things we've talked about. Make sure you know the mathematical assumptions. We already covered that earlier with X bar and P hat. So again, a lot of the same stuff you've seen in the homework and the worksheets. As I mentioned earlier, the test will feel a little bit longer. There'll be a couple fewer questions, so it'll be a little bit fewer questions there, but there's a few more thinkers, okay, than before, so it's going to feel a little bit longer. So make sure you study it. Make sure you know the base concepts really well. Again, think about it like a language. Statistics is its own language, right? There's a handful of things that we need you to know. It's not so much, I don't love memorization. It's not that I'm trying to get you to memorize things. It's just that I need you to be able to speak the language because we're in this course. And so I need you to know some of the basics. That way later on, when we're talking about things, I know that you know what we're talking about. So that's why we have some of those things in there. So just make sure you know those foundational basic concepts down, and that will help the exam feel a little bit less long. All right, so good luck in your studies, and as always, let me know if you need anything.